Hi, welcome to Brief Introduction to the Bash Shell. My name is Sebastian and I'm giving this course today for the Fundamentals of Neuro Data Science 2021 course. What I'm telling you today will be extensively based on a similar lecture given last year by Ross Markello, and also the very excellent Software Carpentry's Introduction to Shell that I recommend you take a look at after this course to get some additional information that we don't have the time to go through today. Before we get started, the examples that I'll show you today will make use of like some tiny files that I've created. You can download this from the GitHub link up there. I realize it's a long link. It'll also be on the course website. And then please just unzip it into your home directory. If you don't know what a home directory is, then it's on a Mac /user your username, on Windows it's /home your username. And it typically looks something like this, right? So in your file explorer, you'll find it there. Okay, so what is a shell? What is the thing that we're talking about? Well, in very general terms, a shell is a program that interprets your input into something the computer can understand. And we'll be talking about today a shell that takes text-based commands that you type into a line. That's why we call it the command line interface. There are also graphical interfaces that you're probably familiar with, but we're not talking about today. And when you type these commands, the command line, or the shell expects you to write them in a scripting language that is a shell scripting language. Right, and this is typically what you will be seeing. So here you have a terminal program. So this is something that the shell can be run inside of. And you can have different terminal programs if you want to. Usually you have a default one that comes with your operating system. And so this thing here is a shell command, and then the little $sign here tells us that the shell is waiting for input. If we run it, we get something back, an output, and so this is inside this window we have the shell program that we're running. And right, so why do we differentiate the bash here specifically? Well, there are different types of shells. Some of it is historical, some of it is community-based. So bash stands for the BourneAgainSHell, which is an iteration of the Bourne shell, which is just sh usually. And the reason that there are different shells is that they do some things differently. Some have additional capabilities, and we're telling you about these other shells here mostly so you're aware. If you talk, if you use neuroimaging software like FSL, FreeSurfer, AFNI, some of their scripts or their examples are using other shells than bash. And why we're talking about bash? Well, bash is the most frequent shell across Unix systems like Linux and Mac. This is a slide from Russ's talk last year. I'm personally not familiar with Mac, but apparently they have changed to the Z shell, which is another shell that's very powerful. You can still have bash. Bash is also the default on the Windows subsystem for Linux. And generally, it's easy to migrate between these shells. They just do some things a little different. So you might be wondering, why did we talk about the shell at all? You already know about the graphical shells and where you can click with your mouse and drag things around. Well, on Unix systems, the shell is extremely powerful, which means that you can typically do everything that you can do with your mouse, also in a command line. And that becomes especially important or useful when clicking things with your mouse takes many clicks or is a very laborious task, right? So it's great at automating things that doing manually is a bother. The other thing that's really good at is to make things reproducible, which is really important when we're talking about this in a science context, because rather than telling somebody where you clicked and what you did with your mouse, which usually they won't understand, you can just write down each command that you've done in the right sequence, and then this text file that you save them in is itself executable. You can run them again as many times as you want, which is a great way to document them. And lastly, many of the tools that you'll be using, and also some of the services that you'll be interacting with, for example, remote supercomputers, they expect you to have some familiarity with the command line and at least be able to do basic things like the ones that I'm going to show you today. And just a caveat here, we will not be able to cover everything today, but the idea is to equip you with some of the tools that you need to understand general concepts and then go and look for the documentation on your own. Okay, so this is what the bash looks like, at least in Linux. If you want to follow along, this would be the time to open your terminal application and then just enter some of the example commands that I'm using here. Okay, so what are we looking at if we open a bash, a shell, a terminal with the shell inside? Well, we get something called a prompt. So in the case of bash, this is a $, and the prompt tells us that, hey, the shell is waiting for input, let's type something. If you are following a tutorial online and there is the prompt in the tutorial, don't copy that. This is not part of the command, right? So just copy everything after the prompt. Okay, so first thing you want to check, are you actually running bash? Because there are other ones, right? So we can check this with a simple shell command, like this one. And if it doesn't say something like bin bash or user bin bash, then you're running something else. You can just type bash, hit enter, and then you will have the bash shell. And also, by the way, this was the first time we ran a command together, and the command here was echo, which is a program that prints something to our screen, right? So we'll look at other commands in just a second. Well, the thing that we had echo print here, the $shell thing, you might be wondering, what is this? So this is something called a variable. And more specifically, it's an environment variable. The reason we know it's a variable is because it was accessed with this $sign. So if you have a string, especially an all-cap string with a $in front, it usually means that this is referring to the value of a variable, and we'll look at variables later in the talk. And so environment variables are variables that your shell is already starting with based on some config files that you have, and they can change certain behaviors. For example, the fact that you have color when you do certain commands, that they're colored, that this is controlled also by environment variables. Okay, the important thing to remember here is that the $ can also be used to access value is assigned to variables. Okay, so what can we do with the shell? Well, the first thing we want to look at is how do we navigate to different directories and do stuff with files in the most general sense, by looking inside of them and maybe moving them around. So one thing to think about that you're not necessarily familiar with if you're only using the graphical file explorer or something is that everything that happens on your computer happens on the file system, and the file system is a hierarchical tree-like structure that gives every directory, every file a unique place on your computer. And so when you open a shell or command line, it is in a unique place, right? And we call this place the working directory. So if you're writing commands that are expecting to be, like, if you ask the shell to show you where you are, for example, it will do that with reference to this current working directory. So one way of knowing which working directory you're in is to use the pwd command. And so here it tells us something that is called a path. We'll look at what that means in more detail in just a second. But so pwd stands for print working directory, and you'll notice that a lot of the shell commands that we're looking at today are generally trying to be abbreviations that are also helpful to remember what the thing does. Okay, so what's going on with the file system? So the file system, as I said, is a tree-like structure, and it has an origin. It has like a first directory, and that's called the root directory. And we will denote this root directory with the /. I think that's, yeah, forward, I think that's how you call it. And then under the root directory, you have a number of directories that are usually used for system-related things, and their names might differ a little bit. So this is based on a Macintosh. For example, the user directory on Linux is usually called /home, but generally the structure is equivalent. And yeah, exactly. So same principles apply whether you're on a Mac or on Linux, and each of these directories contains other subdirectories and files. So when we run a command like pwd and we get what I said was a path back, we can see that the // character can have two different meanings. So as we've already seen, it can refer to the root directory, so the first directory, and it can also be a delimiter between directories, right? So here you can see this stands for the root directory, and then we have the home directory, and then we do another transition to another directory, and in that way we can think of them maybe like jumps, right? So where we are is under root in the home directory, in the SUX directory, which is my user directory, and then in the shell course directory. Okay, so let's take a look at what's in the shell course directory, because that's where we currently are. For this, we can use a command called ls, and ls just lists the contents of the directory we're currently in. So this is the shell course. And just to prove to you that this is actually the same thing, let me show you here, right? So we're looking at the same things. If I open my graphical file explorer. Okay, so this is nice, we see what's in there, but the really powerful thing about shell commands is that we can give it options. So let's look at how a shell command typically is structured. So if we do ls -f interesting files, then the behavior of what we've just seen changes a little bit. We get the color, there are these new characters here, and the reason that it changed is that we have the command as before, right? This is the first character. Then we have something called an option, and then we have something called an argument. And with these things, we can change the way ls in this case behaves. So let's look in a little bit more detail at these. So flags, as we've just seen, we use -f, but we can look at other ones. They're typically denoted with a dash or a double dash. They're case sensitive, and they change the behavior of a command. So let's say we use -l. That will cause the return of the ls command to be printed as a list, right? So now we can see more details, but also it's a list of things. There are other commands. So for example, s allows us to sort things by their size. So if we add that, we will sort the things by their size. But in fact, let me just show you that that's what happens, right? But we can also combine them. We can say, oh, I want L and I want capital S, and then we can have a list that is sorted by the size of these files. And then the last thing is like what we call an argument or a parameter. So if you just run ls, it'll happen in the current working directory, right? This is the default behavior. Some of the commands have default behaviors like that. And if I give it an argument, then the behavior changes, and I say, well, list all the contents not of the current working directory, but of the flying circus directory, right? And if I do this, then my returns change. Right, and ls, as I said, has this default of just printing what's in the current working directory. Okay, now how do you keep track of all of these different options and these things? Well, there are two ways of doing this. So man, I don't actually know what it stands for. I believe it's manual, like read the manual, is a really powerful program that lets you just look at the doc string basically of a given program. So here we're looking at man ls, and we see that there are all of these options. Some of them we've already seen, right? And they all change behaviors. For example, L here, use a long list format. So that's what we already tried. And you can also try ls --help. Whoops. Yeah, you can also try -help. That depending on your system and on the command, can also give you docstring. So the idea is, if you don't know how something works, you don't necessarily need to open Google immediately. You can, but often man will really give you most of what you need. Man gives you, as I showed you, pretty extensive description. there's this other tool that is really nice, what is, that just tells you in descriptive terms what a tool does, not all the options, but what it does. And so it's a little opinionated, so it does not have a default behavior. You need to tell it, obviously, what you want to add. So we can say, well, what is ls? And it'll tell us, it'll list the directory contents. And not every command that you have access to does have this type of description. So if you do what is cd, then it doesn't know what to tell you because this information is not available. But it's a really nice tool, and I recommend that you take a look at it. Sorry, this keeps jumping sometimes here. Okay, well, since we already heard about cd, let's take a look. So we've looked into directories, but we haven't changed our current working directory, and this is actually something we want to do all the time. So let's take a look at the command that we use for this, which is called cd for change directory. And if you do cd change directory, this is analogous to opening a directory in your file explorer, as we'll see in a second. So let's just say see where we are. We're still in the shell script directory, and then if you do cd flying circus, we should have moved our current working directory to the flying circus subdirectory, and we can check that by running pwd, and then we can see, oh yeah, we're now no longer just in shell course, we're in the subdirectory flying circus. This is how cd works. Okay. So does cd have a default behavior? Let's check. Well, where did we end up? And it turns out we're now in my home directory. Okay, that's actually very convenient, because sometimes if you get lost in your file system, which can happen, you can just type cd with no arguments, and it will directly bring you back to your home directory. The tilde character is a shorthand for your home directory, so you can also type cd tilde and it will take you there. So, I mean, that wasn't very impressive because we were already there, but this also works. And then the minus is another shorthand which stands for the directory you were in before the last cd, right? So if I hadn't run this tilde character, I could do cd minus and I would go back to the shell course directory. Okay, so let's actually do that. Let's go back to the directory we were just in. So now I will, because I'm in my home directory, I can say shell course flying circus and then make sure that I am in fact now there, and I am. Okay, great. So you'll notice that rather than just typing the directory name once and then running another cd for flying circus, I actually said, well, go in shell course and then also go into the subdirectory flying circus directly. And I can do this because we can string paths together with the separator that we looked at before. Now the important thing to notice here is that the path that I've given cd did not start with the slash, right? So it did not start with the root directory. And so we call these kinds of paths relative paths because they will be interpreted in relation to your current working directory, so where the shell is currently at. And if I ran this again, now that I am in the flying circus, it will not work because there is no subdirectory shell course in flying circus. Right, so it complains about that. And by the way, I will see this more, but Bash usually tells you if something's wrong in more or less useful ways. Okay, so just let's take a very brief conceptual look at this differentiation. So if you look at a path and it starts with a slash, that's the first character in your path, then it means that's an absolute path, because it tells you in absolute terms with the origin of the root directory where you want to go. If it does not have, or it does not begin with a root character with a slash, then it's a relative path, and it means that the path has to be interpreted with respect to where you currently are located. And as you can think, if you change where you're located, then the path either works or doesn't work, so sometimes it's more useful to have absolute paths. And as we've seen, pwd always gives you absolute paths that start with the root directory. Okay. So now that we're inside of Flying Circus, let's take a look at what we have there. And we can see there's different files, and there's also dangerous rabbits, and maybe we don't want to be there. So let's go back. well, how do we do that? How do we go up a directory, right? So far we've only gone down in the tree. Well, there's a shorthand notation, cd ... that stands for the correct, the directory that is above the one we're currently in. We're also calling it the parent directory. So just to make sure that we have in fact gone one level up, you can do pwd again and see, okay, we're back in shell course. Now you might wonder, we just ran ls and now we did ... so what is ... Why didn't we see ... And that's a great question. The reason for this is that there are certain things that are usually hidden from what ls shows you, right? And they start with dots often. So if you want to see them, you can use another option or flag. And you can say ls -a, which is just show me everything, all the things. And so now you will see that in our shell directory, there are actually more things than we saw before. There are all the other things, and then there's there's ... and there's also I'm hidden. And so ... refers to the parent directory, and dot refers to your current working directory, the one that you're currently in. And as I've just said, there's also this hidden file that we haven't seen before, and if you encounter something like that, typically this is reserved for configuration files or other things that exist, for example, in your home directory, and that you don't want to see every time you run ls, generally speaking. Okay, so let's do a little summary. The file system is kind of the foundation of everything that is a file or a directory on your computer. Any reading and writing operation happens in the file system. And you can move between directories on your file system with the cd command. You can list the contents with the ls command. pwd tells you where you're currently at, prints it out. And then remember that the / character can be both the root directory and a separator between other directories within a path. And then we have these shorthands of ... for the parent directory and single ... for your current working directory. Okay, so now you know a little bit about navigating around your file system with a command line. Now what about actually doing something there, manipulating the file system? Well, we can also do that. So let's just make sure that we're in the right place. We're in a shell course directory, that's great. That's in there. Same things as before, haven't done anything. So let's say we want to create a directory in there that isn't yet there. Okay, so the command for this is called mkdir, and that stands for make directory. And so let's say we want to take some notes, make a note directory, right? So I use this command, and as you'll notice here, the argument notes did not start with a /. So mkdir interprets this as in the current working directory, create a notes folder rather than in the root directory if we had used the /. So we can check that in fact we now have a new folder here, and you can see that there is notes. Oh, and I don't think we've talked about the -f flag yet, but what it does, it gives you these additional characters that tell you what type of thing you're looking at. So if it has a / at the end, it's a directory. If it has a star, it's an executable file, and so on. You can read about that if you want in documentation. Okay, and as I said, all of this that we're seeing here, same file system, we can take a look also in the File Explorer, and in fact, if we do that, we see here there is now a notes folder that I created in the command line, but can also see in my File Explorer. Okay, so something to keep in mind when you're creating directories is if you're coming from a Windows background, directory names can contain spaces, and they often do. That's generally not a great idea on Linux because you need to escape them, something you can take a look at. There are also some reserved characters, so try to just use underscores to replace spaces, or you can use a dash or a dot if you need to. Okay, so let's say we want to actually take some notes, right? So what we can do is go to the notes directory with the cd command. Just make sure that there aren't any notes there, which would be a surprise because we just created the directory. And then we can write a note, and for this we can use a command line text editor, which is called nano, and I'll show you in a second how that works. So let's say we just go in there. I'm not going to run nano in here, but nano is a cool text editor because it is not a graphical text editor. So you're probably familiar with graphical text editors like gedit or Notepad, or even command line editors. There's Emacs and Vim. And so nano is a very, very bare bones command line text editor. It looks a little bit like this. And you can write text into files with it. And I'll just show you in my command line very briefly. So I think in my command line, I'm actually not in the notes folder, so let me move there very quickly. Here, pwd, I'm there. And now I can say nano my note txt. And I can write something like hello dash I am learning things. And then the thing to keep in mind for nano is that it has these key combinations to do certain things, and it tells you at the bottom basically the upward arrow, not sure what that's called, flex thing is stands for the control key, and so this G means hold control and G together, and then the M stands for the alt key, so M minus U means press alt and U. And so if we take a look at this explanation here, then to write out what we just wrote, we have to use control and the character O. So let me just do that. And it asks me, do I want to write to this file? Yes, I do. And then I can use control and X to leave. Okay. So I've just written a note in my command line, right? I mean, you can do this without opening any graphical environment. And so nano doesn't tell us that writing is done, so let's just make sure that we have in fact created a new file. And we can see, yes, indeed, there is a file, mynote.txt. And we can use another command line program called cat to take a look inside of my note. And we can say cat my note, and we will see the thing that I just wrote. Okay, so that's really great. We now know how to create and write text files. There are other ways of creating files. I won't go into much detail here, but you can read up about them online. Okay, so how can I move things in? Right, so copy, moving, this is something we often do. Well, let's first go back to our shell course directory. Take a look inside, make sure that everything looks as we expect it to. We now have the notes folder, but everything else is the same. And let's just say that there's this sketchy looking directory called Deer of Doom. Let's take a look inside that, right? So let's cd into Deer of Doom and do an ls of the contents. And so we can see there is a file and there are two directories in there. So let's take a look inside the directory called the wrong deer, and we see oh, there are many files in there, and they're all in the wrong directory. Okay, so let's say we want to move them to the right directory. How can we do that? Well, there's a command called mv for move. And the way it works is we say move, and then the first argument is the file that we want to move, and the second argument is the directory that we want to move it to. There are other ways of using it, but let's just say for our purposes right now, this is what we want to do. So we move from the wrong directory, a relative path, myfile1.txt, to the right directory. And yeah, so this is just what I told you. First argument is what we're moving, second argument, or last argument, is where we move it to. And we can now list the contents of the right directory and see that, in fact, well, we didn't list them before, but you can believe me that it was empty, and we can now see there is my file. And in fact, if we do a list of the wrong directory, then we can see it's no longer, my file 1 is no longer there. Okay, so we moved it, that's great. Now, there are 4 files in there, and you know, we don't want to write 4 move statements, so we can actually have move operate on more than one file. So this is, let's say we want to move file 2 and 3, and we can just combine, we can just add file 3 as an additional argument, and because the command is interpreted as move everything, move all of these arguments into whatever is the last argument, they will also end up there. Right, so if you have thousands of files, you probably don't want to type all of them in here, so we have something that makes our life a lot easier, and that's called wildcards. And so wildcards are just stand-in characters that can expand to match certain patterns, very simple patterns. And so we have two that we want to look at here. We have the star or asterisk, and that will match anything, any character, 0 or more times. And we have the question mark that will match any character exactly once, right? So if we do star.txt, we will find files called a.txt and any.txt, and if you do question mark.txt, we will find a.txt, but not any, because we expect that after the one wildcard or joker character we get the .txt. So let's say we want to see what files are in the right directory, but now we only want to see files that are called my file and then a number, which coincidentally are the only files in there, but let's just say we use the wildcard for this, then we'll see it'll find all of these files. Now, important thing to remember, moving is actually destructive in the sense that the thing that you're moving away is gone, and you can overwrite something of the same name if it already exists, right? So be very careful with the move command, and you can use the -i flag to do this interactively, so it'll ask you, do you actually want to move with warnings, basically. Right. So another thing that we might want to do is not move, but just make a copy. And what we can do here is, let's just say, okay, we have the files that we want in our right directory, and let's make a backup of that, right? So we make another folder called backup, and now we can start copying files from the right directory into our backup directory, and we use the same structure as the move command, just with cp in front, and we have now just copied my file 1 to the directory backup. Right, so let's say we want to know if this has succeeded. Well, again, as before, we can run multiple commands, or we can just use wildcards. And in this case, what I'll ask is there any directory name, right? So this will match any directory name that contains my file 1, then show me the file, and I will, when I run this, I can see that I have a my file 1 in my backup, and I have a my file 1 in the right directory, which is just what I would have expected if copying works as I wanted to. Okay, so now let's say, you know what, everything in the right directory is great, let's just back all of this up. Can I do this? Right? And the answer is no, you cannot. You cannot copy a directory in this way. You have to use an extra flag here, which Bash actually tells you. It's the recursive or -r flag. And so if you want to copy the right directory into backup, then you have to run it this way. And if we look inside backup, it now has both the file 1 and the right directory just copied over. Okay, so that's how you copy directories. Okay, so how do we remove things? If you remember from the first time we looked into this Deer of Doom, there was this large file. Let's take our option that we know from before and list things by size, and then there's also this H option here, which is really useful. It stands for human readable, so rather than a bunch of numbers, we now get things in kilobytes. So 10 kilobytes is not huge, I guess, but for the sake of the argument, for a text file, it's pretty big. So let's say we don't want this anymore. It takes up too much space. Well, we can use the rm for remove command, and if we run this with the argument, so rm luckily does not have a default, right? If you don't tell it what to do, it will not remove anything. So if we tell it to remove this file, we can then make sure that it's in fact no longer there, and it is not, right? So this is the interesting thing about ls. If you tell ls to list without an argument, it'll just list the current directory, but if it's with an argument that is a file that doesn't exist, then it'll complain and say, nope, I don't know how to find this doesn't exist. And I mean, we can also just run it without, and we will see that big file with no purpose is gone. Okay. Something to keep in mind is that the shell does not hold your hand, and this is actually, you can consider a downside. I mean, all this freedom comes at a cost in a way, and that is, if you delete things, they're gone, never coming back. And that's why you have to be really, really careful with rm commands, especially, and this is a huge warning, if you combine rm or move with wildcards, be super, super careful. And often it's a great idea to do ls first and see that you're really looking at the files that you're hoping. And then there's also the -I as the interactive mode, which is a little bit safer because you get prompts to confirm that you want to do this. Right. So if we now say we no longer want the wrong directory, we'll actually see that as with CP, you can't just remove a directory in this way, right? And Bash tells you this. You also have to use the recursive flag here. So we can say, okay, remove -r the wrong directory, and then it's gone. Again, forever with all its contents. So keep this in mind. Be careful. Okay. So as a summary, if we want to copy things, it's usually old path to new path. mkdir is the command we use to create directories. Move, like CP, can move things around. It can also, because it overrides, rename things. So if you say my file.txt to my grade file, move my file to my grade file, in the same directory, you will just rename the file in effect, right? If you're not moving it to a different place, changes the name, and yeah, I guess you get the idea. rm removes things, and then we've also learned about wildcards, which are great to just match more than, you don't have to type out every single file name. You can just say, for example, if you want to copy all of the contents of a directory, you can say cp star, something like that, or have a real pattern. And important, again, there's no trash for the shell. Things you remove are gone. Okay, so let's talk about finding things with the shell. So we've moved around, we've created things. How do we find things? And this is actually a bigger problem than you might think from these little examples that we looked at, because the file system is huge, and especially when you're looking at scientific directories with many thousands of files often, or you've written something down, you want to find something, it's often really tricky to just cd everywhere and then list everything. You don't want to do that hundreds of thousands of times. So obviously there are commands that you can use that will do this for you. So let's go back to our shell course, and again, which is always a great idea, run ls, run pwd. At some point you'll just do this because you want to make sure you're in the right place, things look right. And yeah, get your slides to advance. Okay, so the first thing we might be interested in is, well, I can look at one sorry, that was the point I wanted to make here. With ls, I can look at the subdirectories of the place I'm currently in, but I can't look inside of them, right? I don't get the entire tree, I just get like the first level. So sometimes I want to know, well, what are all the subdirectories that I have here? And there is a command, it's called tree. In fact, let me show you that what is kind of useful. It says list contents of directories in a tree-like format. So it's very descriptive if you forget what it does. And so if I do this, just as promised, shows me all of the contents of the directory that I'm currently in. And so here you see the Deer of Doom, where we've made some changes, and this is now the new structure, and there's some other ones, and I can't scroll through that, but this is what tree gives us. Now, tree has a number of options that we can use to only show certain things or not show. So for example, you don't want to do tree on the root directory because you get your entire file system and just get thousands of pages on your command line. So it's great for some things, but often you want to find specific things, and for this there's find. So let's say we want to find anything that has a file name roughly like this, my underscore. So for example, like my files that we looked at. So the way this works here, and I'll generally let you figure this out on your own, but so find, and then in the present working directory, which is the dot, and then we have an option name, but the option actually takes its own argument. So the fact that they are written next to each other is not a coincidence. So we want the name that follows a certain pattern. This is kind of how you can read this. And if I do this, I get all of these results. So you can see my note that we wrote. We can see the different my files that we have in the Deer of Doom. And there's this other thing called my lines, which is a directory. And so if you remember, dot means my current working directory. You can see that they don't quite start with a slash, they start with a dot slash, which means start in my current working directory, divide next directory, flying circuit, right? That's how you can read this. So if a path starts with a dot, it means it starts in your current working directory, I guess very explicitly. Okay, and I explained a little bit what name does. Now let's say we don't want to look at this directory up here, we only want to look at files. Then find also has options. We can tell it to only give us the type F, which is type file. Again, if I wanted to know what all the options are, I would use man and read that manual. Okay, and you can see now we only have the files and not the directory. So find is great, but it only operates on the names of the files. So sometimes, especially for text files, you want to see what's inside the file. You want to search for something inside the file, because that is really, really powerful and not necessarily that common to have, I think. I mean, there are some tools that index the contents of your files, but anyway, something that you can do very well in the command line. So the tool for that is called grep. Abbreviation isn't the best, maybe. It stands for globally search for regular expression and print matching lines. So that's pretty long. Again, if you forget what it does, you can use what it is. And it's a bit more explicit. It prints lines that match a certain pattern in a file. Okay, so in the directory we're currently in, there's this text called hello world. Let's see what kind of text is actually in there. And we can see it says hello bash. So we can now say, okay, well, please find me the line in the hello world text file that has bash in it. And because there's only one line, it'll give us only that line back, but it'll conveniently make the word bash red. That's the most basic way we can use grep. But we can do other things. So Flying Circus, the directory, actually contains movie scripts from Monty Python movies. And we just happen to know that only one of these movies has a rabbit in it. And we could use grep to find out which one it is. So we could say, look for the string rabbit in all of the files in the Flying Circus directory. So this, remember, is a wildcard. And we can say count to just give us the the number of times that it occurred, not necessarily the actual lines, because that might be many. And then no messages is another option that, anyway, you can look them up in the manual. So here are all the files that it looked inside, and you can see that all of them have 0 occurrences of rabbit except for the Holy Grail. So there's apparently a Holy Grail, a rabbit occurs in the Holy Grail movie script. Now notice that the file Dangerous Rabbits was actually not a match, because grep looks inside of the file rather than in the file name. And yeah, so if you want to look at man, I mean, we've already done this, so I can't scroll, so maybe try this in your own time. Okay, little excursion here just for a second. Something called pipes is very helpful in Bash, and in the shell. And one of the main features of shell commands is that you can string them together in something called pipelines. And so what this does is that rather than, so if you write ls, right, it'll show things, print them on the screen. So rather than print them on the screen, we can say, well, take all this output and give it to the next command. And so we can kind of stick them together like a pipe. Or I also like to think of it as like a relay race, where you just like hand over the baton once you're done with your round. And so the general structure is you have a command with its flags and arguments, and then you do this vertical character, the pipe character, and you write the next command. And that just means take the output of the first command, give it to the second command. And this is really useful. I'm not going to go into more detail. You can read in your own time what the different options are there. The reason I showed it to you is because of this next example. So let's say we've heard that in one of these movie scripts, or let's just say we're interested in if there's any place in the movie scripts where somebody says ni, or ni is mentioned. And because we expect this to happen relatively frequently, we only want to see the last 10 occurrences, right? So if you just do grep, it'll show us all of them. And if we just want to see the last 10, we can say, well, take all of the things that grep finds, give them to another command that gives me only the last 10 lines of this output. So tail does this, and we can say, okay, what is tail? Well, it gives you the last part of a file. In this case, the file is the input that it gets from grep. So here we use look for ni in the Holy Grail text file, and we want to see the line numbers. And anyway, the important thing here is pipe. The pipe character says give all of the stuff that grep finds to tail and give me the last 10 lines. So this is what this would look like. And here we can see with the line number and the file name, every time somebody says ni, or there's some ni going on, like 9 also gets matched, and niki. But yeah, that's how we can pipe things together. And I mean, this is a very simple example. We could have actually achieved very similar functionality without the pipe here, but just to show you how this works. Now, the reason that pipes are actually not only useful but sometimes necessary is that in general, shell commands in Unix follow the Unix philosophy, which is do a single thing very well, right? So typically each command has a very narrow scope that it tries to do very robustly. So if you want to do different things, you will have to use different commands, and pipes are a great way to combine the functionality of different commands. Okay. So what we want to do now is just one more example of grep, and that's often useful. Grep lets you actually see into the context of where you match something. So let's say we want to know if there are any occurrences of the word swallow. Then we could say, well, we only want the first 10 in this case, right? But we want to see the next line after the one that matches in any of the files of the flying circuit. So what we will get is, across these movie scripts, anytime somebody says swallow plus the next line, up to 10 hits. And if we do this, you can see that grep finds this pattern in the Holy Grail in different lines, and we can often, sometimes there is a second line directly after it that doesn't have a hit, but we also get printed, right? So you have a bit of an easier time understanding maybe what was being said, and if you've seen the movie, that this is some kind of gag about swallows carrying coconuts. Okay, so grep, super powerful tool. Let's do a quick summary. So we've seen the tree command gives you a tree-like representation of either the entire file path, usually not useful for that, or your local file path under your current directory or any other directory you want. Find is a great way to search file names and directory names. You can also search based on other metadata that like size and age and so on. You can look up how to do that. Grep's a great way of searching inside files, text files. And then pipes allows us to combine things. Okay, that's already quite a lot. The fourth thing that I want to show you today is how you write your own commands and your own scripts, basically. So, as I said in the beginning, one really, really powerful thing about all these commands that we're typing is that we can put them into a text file and then execute it, and it'll do the same thing as when you type them one by one and hit enter every time. And the reason this is so useful, obviously, is maybe you want to do a certain command many times, right? So either at a certain time of day when you log in every different directory, you don't want to type it again. It's great for that. If you want to keep a record of what you've done, so for example, if you run an analysis pipeline, if you have the script that you if instead of typing it out every time, you have a script, it's a comprehensive documentation of what you've done, as long as you can read these files. And you can also share those with somebody else and they can do it on their own data. So what do we need? What is the magic that turns a text file into a script? So let's first go into interesting files. And take a look inside. So here you can see that -f gives files that are executable, and we'll see in a second what this means. This little star and also the green. But we have different files that end with .sh, and those are script files. So let's take a look inside one of them, this cat. So when we do this, we see that this is what the script file looks like inside, right? It's not very complicated, but there's a number of things that are typically needed for script files. So the first line actually is called the hash bang or shebang, and the reason it's called that is because this is a hash and this is called bang, and it tells when you execute the script, it specifies what shell you want to interpret the commands inside the script. So here we're using bash, but you could be picking any of the other scripts, and in fact that sometimes, like we said initially, you may want to do this. So pick another shell that is supposed to run this. And then here we see the echo command that we've already seen, and it has some text that it's supposed to print. And then what we also see, so now I have to scroll, but I'll just explain to you here. We see this hash again. So in this case, it's used as a comment, which means that any text after the comment in the same line will not be executed. So the shell will just ignore this. And so comments are a great way of annotating in a human readable way what the script does, right? So in our case, the comment says this will print a message, which we know because we know what echo does, but it's still nice to have. And then the last thing is we typically call these text files .sh to show that they're shell scripts. Okay, so what happens if I run one of these? Again, ls-f gives me a little asterisk if I have an executable script. We'll see in a second what this means. And if we now run me.sh, it will print to the screen, "Thank you, very kind," as we've just seen in the when we looked inside. Okay, so we ran our first script. There's another file called runme2, and it also ends in .sh. And the question here is, I mean, obviously the answer is no, but the question is, could we run this in the same way, right? And if we try, it will not succeed, and bash will tell us the permission is denied. So what could this mean? Well, if you look, first of all, it's not green, it doesn't have a star, but if you forgot to use the -f flag, what you see here on the left are the permissions that files have. And this is kind of a complicated topic in its own, and you're welcome to check it out. But for our purposes, the thing that we're looking for here is R is read, W is write, and X is execute. And so this file does not have execute permission, right? There's no X here, but the other two have. And we can change this with the chmod command, and we can just say, there are other ways of being more specific about it, but we can just say give +x, give execution permission to this file. And after we've run this, we will see that this run me2 now is also green and also has a star, right? And so the reason this hasn't changed here is because I would need to run it again, but yeah. Okay, so this is now execution permission, and if I run the script, it will no longer fail, but it will say I didn't have execution permission, and now I do. That's great. Okay. So you might wonder, well, how does the shell actually know where to look for the commands that we type all the time, like cd and ls, right? Because if I type just run me, it won't work. It will say command not found. And what I have to do is I have to say in my present working directory, run me, right? Execute run me, and then it'll work. Okay. So I have to give the path to this command, but I don't have to give a path for cd, and I don't have to give a path for ls. So how does this work? Well, the command line actually has a number of directories the shell has a number of directories that it'll go inside of and look for a command with the name of the command you just typed. And bash is actually pretty clever if you mistype something. So if you have double character, pwd, it'll generally tell you that, it's not exactly, I don't know what to do with this, but there are other things that have a similar name. Maybe you meant that. So pwd, for example, you can install this other guy here. So that's nice, but where are these programs that it actually looks for? Where does it look, right? So let's say you actually have a program that's called pwd, and bash tells you this, then you say, no, please find it. How do you make that happen? Well, there is another variable, and this is where we get to the variables. It's called the path variable. So like the shell variable we've seen before, the path variable is an environment variable that your shell starts with. And if we print out the content of it, or its values, so it's an environment variable, not a value. Yeah. So if we print the value of the environment variable, we see that there are all these paths in there, right? And these are all the paths that my shell will look inside of when I type command, and if none of these directories contain my command, then it will tell me, I don't know, the command's unknown or can't find it. And something to note here is that there is this colon character that delimits these different paths, and that's something that we can use to add to the path. Okay, so we still don't know which of these directories ls is in, and for that there is another great tool which is called which, right? So you can say, in a way, which ls are we talking about here? When I type ls, which one are you going to run? And it will tell you the absolute path of the ls that it's going for. And in this case, it's user bin, which is one of the directories that are in the path, so this all makes sense. And the interesting thing here is you can in fact run ls with the absolute path of ls, and it'll also work, right? It's just kind of a convenience that the shell will look up in all of these directories for you. Now, sometimes which is really important, and I want to encourage you to use it often if you have more than one possible version. So sometimes when you work with Python, there could be different Python versions in different locations. Usually that. Anyway, you'll hear more about that later. But which will tell you if you run this command, it'll go to this specific executable, and there is an order to this, right? So if you look at the values of the path variable here, there's an order, and so it'll look at things in this order, and it'll give you the first command that matches. So sometimes if you want to change your path variable, it makes a difference whether you add to the front or to the back. Okay, so that's the last thing I want to show you. I think we're a little bit close to the hour, but almost done. So the last thing I want to show you is how you actually work with variables, like the path variable. And so as I said, the path variable, we didn't define this variable, right? It was already there when we started. And these environment variables typically are set in startup files. They could live in system directories, in the root directory, or there can be user-specific startup files in your home directory. Generally, in your home directory, these startup files will have a leading dot, so you won't see them when you list without the -a option. And let's just say if you start a command line in the way that we've just done, a shell in the way that we've just done, with like opening your terminal program and then having the bash prompt in there, then you can control your environment variables with the .bashrc file. Right? So I have a .bashrc file. You probably also have a .bashrc file. There are other startup files. They're called profile. That's the more general profile start file, and you have bash profile. And I won't go into much detail for what they do. We've already seen what cat does, so it prints files back to the command line. But we want to use cat now to take a look at my bashrc file. And because my bashrc file again is long, I'm piping this output over to tail. Tail by default gives me something like 10 lines. So there we go. Now you see in the last line of my bashrc file, there is a path equals path statement. And so what this means is I reassign to the path variable itself, right, the value of path, and then I use this colon delimiter, and then $home is another variable that is just stores where my home directory is, and I say, okay, well, please add this /bin directory to the end. So that's what this does. In line 120, it adds this to my path. Now, you'll notice the export statement, and this is actually important. We'll talk about it in a second. This turns the path variable into an environment variable, right? And I mean, this is kind of a nonsensical statement here. I'm not actually using this, but just to give you an idea, this is what it's not a nonsensical statement. Often, if you some tutorials, some installation instructions tell you to add something to your path, this is how you would do it. That's what I wanted to say. Okay. Oh, and just so we're completely clear, yeah. This, slides are a little bit slow while I'm recording. So what we have done here is we have added our new folder, the directory that we added to the path at the end of the path. So we could have had the whole thing like this first, then colon, then path, then we would have added it to the front of the path. And if we had in this home directory /bin any command that is conflicting with, let's say we have an ls in there, then it'll go to that first and not to the one that you expect. So changing the path actually changes the behavior. And that's another reason why you want to do it at the level of your user, because if you do it at the system level, first of all, it won't let you. You have to override the permissions. But you can actually change the way that your entire system behaves. And that's typically not something you want to do. So to keep it in user-specific folders. Okay. So now for the last bit, the path variable is important, the shell variable is important, but at the end of the day, they're just normal variables, and you can create more of them, right? And the statement for that is very simple. You type a name, then you use the equal sign, and then you assign it a value. And you can now look at this variable, and with the dollar sign, we access the value of it, and it prints back 10. So a couple of things to note here. Variable names are case sensitive. We use, as I already said before, the dollar sign to access the value of the variable. And then I've used these curly braces here, and the reason I do that is because sometimes it's important to be very specific about what part is the name of the variable and what isn't. So I have a couple of examples to show you how that can fail. So if I don't type the dollar sign, then Echo thinks this is actually just a text it wants it to print, so I don't get my value. If I use small caps rather than all caps, I also don't get my value because that's not a variable that exists. And if I say my var is cool and I expect it to print 10 and then is cool, it won't work because the shell doesn't know where this variable ends because I hadn't used my, my curly braces. So I don't get anything because a variable with this name doesn't exist. But if I do add my curly braces, then I get the behavior that I expect. 10 is cool. Okay, so that's how variables work. And then the last thing we want to look at is that there are actually two different types of variables. And I've already talked about environment variables, but let's be very explicit. What I've just created there with the equal statement is called a shell variable. And it only exists inside of my current shell. So I can echo it, I can change it, but if I start another program in my current shell, this variable will not be available to this program. So if I inside a script, for example, talk about my var, it'll be undefined. Environment variables, by contrast, are variables that get inherited or that get passed on to commands or programs that you call inside your shell. And so this can be really important if, for example, you want to store certain configuration options inside an environment variable that then the program you're calling is looking for or is reading into, right? And so the way that you promote, quote unquote, a shell variable to an environment variable is this export command that we've seen in my bash rc file. You can also do the opposite. You can demote them with export -n. And there's a command that tells you what environment variables your shell currently knows about. So if I print the ones that my shell knows about, again, just the n because there's a bunch going on. Here you see the path variable that we already looked at. There are a number of other ones. This is also interesting when you remember that cwdd the minus brings me to the last directory I was in before the one that I'm currently in. Then this is actually what it looks for, right? The old pwd, the old working directory in a way. I think. Better check. Right, so let's take one last look at the environment variable versus shell variable and how that works. So we have a script, it's called I can see variables, and what it does, in fact, let me show you. I hadn't planned to show this, but interesting files, right? So I can just show it here. I can see variables. You know what? Oh, that won't work. Interesting files, right? And I can just say I can see variables. Okay, so maybe that's not that helpful for you. Right, well, what it does is it looks for two variables that it wants to print. So there's an echo statement here, and it looks for the env var, and it looks for the shell var, right? So there's two echo statements, and it'll just try to print those. And we will see in a second what happens if we define these variables, right? So we say, okay, env var is this string, and then shell var is this string, but we only export the env var. And so, by the way, by convention, environment variables are all caps, shell variables are small caps, just so you don't always have to run print environment. And so if I run this script now, what I would expect is that it can see env var because I've just exported it to an environment variable, and it cannot see shell var because that is still a shell variable. And so if I print here, you can actually see that it says, well, I have seen the value important string. And then here where it's printing the value of shell var, we just get an empty space because this variable is not defined from within the script. The script cannot see this variable because it's a shell variable. Okay, and yeah, I've already talked about this. So because environment variables are available to scripts, for example, if env var would contain some setting that the script can then use to change its behavior, we could control the behavior of the script without actually changing the code inside, but just changing the environment variable on the outside. So they can be very useful, and they're often set by configurations. Okay, so this is, I think, my last slide, yes. So just to recap very briefly what we've done, we said that in your shell, in your command line, the shell is looking in all of the directories defined in the path variable, and you will often hear that you are supposed to add something to your path, and this is the variable you want to change. The place you want to change that variable in is usually one of the startup files in your home directory, like bashrc for bash. And more generally, you can also create and change your own variables. Remember that to access the variable itself, you use the value of the variable itself, you use the $sign. But actually, let me go back because that's important. I forgot to mention this. If you look at this statement here, oh yeah, I put the note in here, but I forgot to say, we export the name of the variable rather than adding a $sign in front. And that's because we want to export the variable itself, not its value. So that's a little tricky, you have to keep that in mind. So there's no $sign in this case because we're referring to the variable and not its value. Because what we want is to be able to refer to the same assignment of env var in the script. Okay, now let's wait until we get the next slide. Yes, okay, so $sign to access the value versus no $sign to access the variable in certain contexts. Export allows us to turn a shell variable into an environment variable, can be very important, and if we write our own scripts, then we usually start them with this this shebang, and we can then make them executable with the chmod command. And if a shell script or a command is not in the path, then we can't just type the name of it, we have to actually type the path to that command in order for it to run. Okay, so this is all I wanted to show you today. Just a reminder, shell is extremely powerful, and it's a very good idea to learn some of these concepts and play around with them. You can just try them out on your own computer. It's great for documentation, it's great for reusability, it's great for efficiency. That said, these shells, or the command line in general, there are certain tasks that are really good at, like the ones that we talked about today, like especially if they involve the file system, like moving, copying things around. But there are, as you will hear later in the course, also other really powerful programming languages, full-fledged programming languages, that offer a lot of additional functionality, better development environments, and debugging, and error handling, and so on. And there are tasks where Bash is great, and then there are other tasks where it's better to pick something like a Python programming language to write, for example, complex pipelines or complex multi-step programs. Right, and you'll hear more about that in the Python course. Okay, so if you're interested in this and you want to continue reading, here are a number of resources. They're again also in the slides. there are many resources online. One thing I want to remind you of is that even within the shell, you can often get a lot of help from man -- help. What is, there are all of these tools that can tell you without actually opening a browser necessarily how to use something. All right, thank you for your attention, and I hope you have a lot of fun with your shell environment.